Good morning, students. Due to internet problem, just half an hour late for the class. Sorry for the disturbance. We'll continue our discussion on P block elements. See, in yesterday class, we studied about the compounds of phosphorus and oxoacids of phosphorus. We studied white phosphorus, red phosphorus, their differences, and how they can be prepared, and what are their physical and chemical properties. And we again studied the compounds of phosphorus, that is phosphine, phosphorus trichloride, phosphorus pentachloride, and at the end we discussed about oxoacids of phosphorus. So you have to know its structure. Oxoacids of phosphorus are phosphoric acid. Its formula is the oxoacids of phosphorus. Oxoacids of phosphorus. So, or phosphoric acid H3PO4. So its structure is phosphorus atom is bonded with oxygen atom, and a tetrahedral structure you can find here. See, this is nothing but OH and again OH and OH. So you can see H3PO4. So how many P2OH bonds are there? 3 P2OH bonds are there. So you go for next orthophosphorus acid H3PO3 again phosphorus double bond with oxygen, and see one of the oxygen atom is here, and this is nothing but again tetrahedral structure, and this is nothing but H, and these two are OH. O3, only 3 atoms. It contains one P2H bond. Like that, so hypophosphorus acid, H3PO2, hypophosphorus H3PO2. So again, phosphorus bonded with oxygen, and again you can find. See, this is nothing but one H bond, another H bond, and this is nothing but OH. So, in orthophosphorus acid, we can find. See, 2 hydroxyl group and one P2H bond. Are you clear? See, in phosphoric acid, all the 3 are P2OH bond. And in, see, hypophosphorus acid, that's the difference. Hypophosphorus acid, we have phosphorus to hydrogen, 2 bonds, PH and as well as P, and only one P2OH bond. Are you clear? Understood? Okay. Then we have to study, see, pyrophosphoric acid. So which is nothing but pyrophosphoric acid. Its formula is see, H4P2O7. See here, 2 phosphorus atoms are bridged with an oxygen atom. See, remaining, it is nothing but double bonded oxygen, and this is nothing but a double bonded oxygen, and again a tetrahedral nature. So this is one OH, and this is also OH, and this is one OH, and this is also OH. Just confirm all the atoms. So this is nothing but 5-phosphoric acid. 5-phosphoric acid. See the structure. In pyro, what is the formula? H4B2O7. O7. See here, phosphorus atom is bridged with an oxygen atom, and all other two P2OH bonds are there. So therefore H4 1, 2, 3, 4. P phosphorus 2 atoms, oxygen 1, 2, 3, 4, 5, 6, 7. For all type of oxoacids of phosphorus, we can find a common bond, that is P2, which is a double bonded. Phosphorus atom is attached with oxygen, and another one is P2OH. So it is any oxoacids, it contains common two bonds, that is one P2O, which is a double bond, and another one is P2OH. So remaining, it may contain, if different in oxidation state, it may contain P2P bond or P2H bond, not both. Are you clear? So you must know the structure as well as how many P2OH bonds are there, how many P2H bonds are there. Are you clear? Okay. So these are the oxoacids of phosphorus. See, oxoacids of phosphorus, they can disproportionate. A compound which shows variable oxidation state, that means different oxidation state, two or more oxidation state in a chemical reaction, that is called disproportionation. Are you clear? What do you mean by disproportionation reaction? A compound in a chemical reaction shows more than two oxidation states. See, take for example H3PO3 ortho phosphorus acid. See, it is disproportionate into 4H3PO3, so you will get 3H3PO4 phosphoric acid, and 4 phosphorus atom is there, another one is 3H3 phosphoric acid. Are you clear? See, phosphorus atom, and here phosphorus acid, orthophosphorus acid, and here orthophosphoric acid, and this is called phosphate. See how the oxidation state changes. In phosphate we can find say +3, so you can easily calculate the oxidation state. So this type of reactions are called disproportionation reaction. See, you studied hypophosphorus acid. What is the formula for hypophosphorus acid? H3PO2. See, it can act as a good reducing agent. It can reduce silver nitrate into metallic silver. A particular example is there for your syllabus. So it shall go for the reaction. See, AgNO3, silver nitrate, silver nitrate. When it reacts with, see, H3PO2, which is nothing but hypophosphorus acid. So in presence of water molecule, 2H2O, you will get, see, silver nitrate, 4 molecules of silver nitrate, you will get silver. So it is reduced. Silver nitrate is reduced to metallic silver. By what? By this hypophosphorus acid. Are you clear? See the equation. Now we can balance this. So it is nothing but here 3 hydrogen atoms, so therefore 3HNO3 and plus 4 hydrogen atoms are there. It should be 4HNO3 See, four nitrogen atoms are here and four hydrogen atoms. And so again hydrogen atom here four and three hydrogen atom remains and here one oxygen. So therefore it is H3PO3. H3PO3. See, two oxygen atom, no, PO4. Two from here, PO4. Phosphoric acid. Easily you can balance. See, I will repeat again the balancing. Silver nitrate is reduced to metallic silver by see hypophosphorus acid. Hypophosphorus acid. 4AgO3 plus H3PO2, which is nothing but hypophosphorus acid in presence of water molecule. So silver nitrate is reduced to metallic silver. So therefore it is a good reducing it. Itself will get oxidized. See, H3PO2 will become what? H3PO4. And we can easily balance how many hydrogen atoms in water molecule? 4. So therefore you have to write 4. Nitrate is also there. 4 HNO3. Are you clear? Very slowly I am going to write the equation. So you have to practice. You can easily understand. Are you clear? So this is called the reduction reaction of hypophosphorus acid. Silver nitrate is reduced to metallic silver. Okay. So this completes our study of 15 group elements. Now we shall move on to 16 group elements. Dear students, what we all studied in 15 group elements, just we have to recall, and I will give the notes and some questions also. You have to write in detail the answers, and whenever we ask, you have to show. Okay. Now we shall continue our discussion on 16 group elements. 16 group elements. The small part yesterday we will is oxoacids of sulfurous, phosphor, and we shall study now 16 group elements. 16 group elements. See, 16 group elements are oxygen, sulfur, selenium, tellurium, and polonium. Name 16 group elements. Those are oxygen, sulfur, selenium, tellurium, polonium. Are you clear? Okay. These 16 group elements are also called chalcogens, and as it is nearer to 18 group, it can easily receive 2 electrons and can attain noble gas configuration. So therefore, their general chemical trend like electronegativity, electron gain enthalpy, ionization enthalpy, we shall discuss now. See how these elements occur in our earth crust, in our universe. See, oxygen, dioxygen, nearly 46.6% by mass. There we can find oxygen. As it is more electronegative, it can combine with many metals and non-metals. So, water contains, this oxygen is highly soluble in water. 100 cm cube of water contains nearly 3.1 cm cube of oxygen. So, which is sufficient for aquatic life, fish and other aquatic life. It's sufficient. Just 3% oxygen is sufficient for the respiration. So, that is nothing but existence of occurrence of oxygen in our atmosphere, in our universe, in our earth crust. Then go for sulfur. See, sulfur exists in many sulfide ores, lead blende, chalcopyrite, CuFeS2, all formulas you know, gypsum salt. All these are the constituent of sulfur. And if you the organic compound which contains sulfur are egg, garlic, many organic compound also metal also contains sulfur. So selenium and tellurium they occurs in a form of then selenites and also tellurides. So polonium it is obtained by it is nothing but a radioactive disintegration of uranium and thorium. Polonium is a radioactive element. Oh. So these are nothing but occurrence of these 16 group elements. 16 group elements are oxygen, sulfur, selenium, tellurium and polonium. Are you clear? Okay. So oxygen, sulfur, selenium, tellurium, polonium. You know, understood that occurrence, how it occurs in our nature. Okay. Then we shall study. We shall study. See some of the chemical traits of this ingredient. These elements. So those chemical traits are electronic configuration. See oxygen second period element 2s2, 2p4. Again sulfur 3s2, 3p4. So they have general electronic configuration ns2, np4. So p orbital contains partly filled 4 electrons. 4 electrons. So again selenium 4s2, 4p, 4. Again 5s2, 5p4, 6s2, 6p4. Are you clear? So general electronic configuration, electron configuration of respective element. So 16 group elements, how many valence electrons are there? You can easily check. How many valence electrons are there? 6 valence electrons are there. Oxygen, Lewis dot structure. You wrote in first PUC. So valence electrons are 6. So this is nothing but the electronic configuration. Then the chemical trends like electronic configuration, then atomic and ionic radius. Atomic and ionic radius. As you come down the road, atomic and ionic radius increases due to say addition of excursion. Third period, fourth period, sixth period, like that, it increases. Therefore, automatically as you come down the road, atomic ionic size increases. Okay. Then go for ionization enthalpy. Ionization enthalpy. See again, these 16 group element has less ionization enthalpy than 15 group because 15 group elements are contained half filled configuration. Here again, partly filled configuration. As you go for again 17 and 18 group. See, therefore, as you ionization enthalpy, as you come down along the group, ionization enthalpy decreases. Why decreases? Size increases. As size increases, electrons are away from the nucleus. The binding energy is nuclear charge is decreases. So therefore, automatically we can easily remove the electron. Ionization enthalpy decreases down the road. Okay. Then electron gain enthalpy. See, electron gain enthalpy. Electron gain enthalpy again, as you come down the group, generally it decreases. But as you compare electron gain enthalpy of oxygen and sulfur, so oxygen shows lower electron gain enthalpy than sulfur. because due to the compact size of oxygen, as 2p orbital lobe, see, I already explained this, the basic class of p block element. If you go for sulfur, electron gain enthalpy is more than oxygen. See, what is the general trend? As you come down the group, electron gain enthalpy decreases. But there is an exception. Oxygen, due to the compact size of 2p orbital, the repulsion between the coming electron and the electron present in 2p orbital. As you go for sulfur, the 3p orbital is lobe is more. So it can easily receive the coming electron. So therefore, its electron gain enthalpy is more. As you come down again from silicon, aluminum, and it's a radioactive, so again it decreases. Only electron gain enthalpy is more for sulfur. Here less for oxygen due to compact size. Okay. Electron gain enthalpy again decreases from the group. Then electronegativity. See, as electronegativity again decreases down the road. As electronegativity decreases, the metallic character increases. See, due to small size, the shared pair of electron can be easily received by elements like oxygen and sulfur. So, as size is bigger here, and electronegativity decreases down the road. Electronegativity criteria is a metallic and non-metallic character can be interpreted by electronegativity. As electronegativity is very less, the elements act as a metal. Okay, so that is nothing but the chemical trends: electronic configuration, atomic and ionic radii, electron gain enthalpy, electronegativity. Okay, we shall see the physical appearance of this existence of these elements and their oxidations. So, oxidation state. See, oxygen, all these 16 group elements, generally they use oxidation state -2, then +4 and +6. As you come down the positive oxidation favors. Again, it is again due to electronegativity, electron gain enthalpy. So we can see here for oxygen, in many compounds, it shows -2 oxidation state. Majorly it shows -2 oxidation. Why? Because it's more electron gain enthalpy, more electronegativity, and its electronegativity is next to fluorine. See, except fluorine, with all other elements, oxygen shows -2 oxidation state. So studied in first phase. See, in OF2, oxygen only is in +2 oxidation state. Are you clear? You study this. Okay. Here, as you come down, the metallic character increases. And again, it is due to inert pair effect. It is due to inert pair. Clearly explain what is inert pair effect in previous class. Okay. So therefore, as you come down, the positive oxidation state favors. Are you clear? Then to go for the covalency, oxygen covalency is only 4 because available orbital is 3. And if you go for sulfur, selenium, aluminum, and covalency exists because availability of d orbital. As you come down again, f orbital, its covalency is more. Okay, so that is nothing but oxidation state. Are you clear? So generally 16 group elements exist, shows -2 oxidation state, and it is favorable to oxygen, and +4 and +6. Are you clear? As we come down from sulfur, selenium, tellurium, so we can find positive oxidation state. Okay. Then we have to study the next part, which is nothing but it's a reaction with. It's a general reaction you have to study for all P block elements. That is reaction with hydrogen, reaction with oxygen, and reaction with halogen, and reaction with metals and non-metals. Are you clear? Okay. Again, I will end the chemical trends, atomic and ionic radiant, ionization enthalpy, electron gain enthalpy, electronegativity, oxidation state, metallic character, and oxygen and sulfur, they are non-metals. These are non-metals. And selenium and tellurium, these are metalloids. Metalloids. But polonium is a metal, which is a radioactive metal. Are you clear? Okay. So we shall study the reaction with hydrogen. All 16 variables, reacts with hydrogen, and forms a compound of type H2E. So it is nothing but a reaction with hydrogen. Reaction with hydrogen. All 16 group elements reacts with hydrogen and forms H2E type of compound. So if suppose E is nothing but oxygen, sulfur, selenium, tellurium. Okay. If suppose oxygen reacts with hydrogen, you will get H2O. Again, sulfur reacts with, so you will get H2S, then H2SE, and again H2P. Are you clear? Okay. These are nothing but hydrates of 16 group elements. Even polonium is nothing but H2PO. See here, you have to compare their acidic strength. So acidic strength increases. See, this is more acidic. So therefore, water is less acidic. Why? It is due to bond dissociation enthalpy. Bond dissociation enthalpy. As the size is more, as it comes from sulfur, selenium, tellurium, so it can easily dissociate. So acidic strength is mainly due to bond dissociation enthalpy. As bond dissociation enthalpy goes on, decreases. So therefore, acidic strength increases. Very important point you have to remember. Why these hydrides shows increase in order of their acidic strength? It is due to bond dissociation enthalpy. Okay, you go for the stability. See, in all the elements, in all these hydrides, you can find in water hydrogen. You can find hydrogen. So therefore, water is stable. Hydrogen sulfide is in gas state, and those are in solid state. See, therefore, stability, water is more stable. So this is nothing but different types of hydrides and their interrelation. Now we shall study reaction with oxygen. Reaction with oxygen. See, all these type 16 group elements reacts with oxygen and it forms say EO2 and as well as EO3 type of oxides. Both the type of oxides you can find. EO2 and EO3. See, it is nothing but oxygen, dioxygen. Then we can find sulfur dioxide, SO2, and even SO3. Then again SeO2 and SeO3. All these oxides, majority of these oxides are acidic in nature. They are acidic in nature. Are you clear? So all 16 group elements react with oxygen and it gives two types of oxides. One is EO2 type, another one is EO3 type. And generally all these oxides are acidic in nature. Sulfur dioxide, see you know non-metallic oxides are acidic in nature. Metallic oxides are basic in nature. If you go for aluminum, which is nothing but a radioactive, very difficult to form compound, so we will skip the compound. Only selenium, even the tellurium oxide, all those oxides are what? Even though they are metal, so it exhibits acidic nature. Those oxides are acidic in nature. So these are the reaction between oxygen. If you go for next reaction with halogens, See, all these 16 group elements, reacts with halogen, and they form. See, the reaction with halogen. And all these elements, see, X is nothing but a halogen. So they form EX6 and EX4 and even EX3. Generally, is EX4 and EX6. So I am going to write sulfur. See, sulfur hexachloride, sulfur tetrachloride, and again sulfur. This EX2, sulfur, particularly Cl2. Are you clear? So these are nothing. Halogen. They are for the hexaderivative as well as tetraderivative. Energy. Here, hexaderivative, tetraderivative, like. So with the halogens, they form several compounds. And for example, hexa, they are in octahedral nature. So SF6, which is beyond the octet rule, which violates the octet rule, but they are stable. See, this is nothing but sulfur hexafluoride. If you go for oxygen and sulfur, they form compounds. Okay, so this is nothing but different types of compounds which forms by halogen. As halogen is more reactive, and these halogens very near to the next group of this is nothing but the 17 group, so they can easily react. Okay, and all these halides are in covalent in nature. They can form by sharing of electron. So these are the reaction of halogen with the 16 group elements. Then if you go for metals, so the element oxygen combines with all type of metals. It combines with say silver reacts with oxygen. You will get silver oxide Ag2O, so therefore it is 4Ag. Okay, it reacts with non-metals like carbon, so you will get carbon dioxide. So these are nothing but reaction with metals and non-metals. It forms respective oxides. Because oxygen is more electronegative, it can combine with all type of metals and non-metals and forms their oxides. For example, silver reacts with oxygen, you will get silver oxide. Again, carbon and non-metal reacts with oxygen, you will get carbon dioxide. It's simple equation. Okay, what you have to remember? The reaction with hydrogen, you have to compare those hydrides, and reaction with oxygen, again you have to compare the oxides. Immediately you will get acidic oxide. And then it's a reaction with what? Halogens. They form generally the hexyl tetra. Are you clear? See, as oxygen covalency is only 4, it cannot form the 5, 6 or more orbital is not there, so its covalency is only 4. Such type of halogen only you can form. Okay, so this is nothing but the reaction with the halogen and reaction with metals. So we completed our study with the reaction of 16 group elements with hydrogen, with oxygen, with halogen, and with metal and non-metals. So now we have to discuss the compounds of oxygen. So that is dioxygen. So which is nothing but a molecular oxygen. Generally called as dioxygen. Are you clear? Dioxygen. How this can be made? What are its physical status and its important chemical reaction we have to study. So we shall study first how it can be prepared. Dioxygen, how it can be prepared? It is prepared. See, dioxygen, it is prepared by the thermal decomposition of potassium chloride in the presence of manganese dioxide, MnO, as a catalyst. So I am going to write the reaction. Preparation of dioxygen gas. See, 2 KCl3 potassium chloride, which is in solid state. So in the presence of MnO2 as a catalyst, and we have to clean. So we'll get see 2 KCl plus 3 O2, which is in the solids. So this is nothing but easily we can prepare. See, before last year for annual examination, they asked how dioxygen gas is prepared from potassium chloride. So it is nothing but by heating potassium chloride in the presence of MnO2 as a catalyst. See, it is nothing but again a homogeneous catalytic reaction, just to compare the reactant and the catalyst are in same phase.